A semicircle having center at O and radius equals to 4 is drawn with PQ as the diameter. Center is O and radius is PO, OQ, OS equals to 4. OSRU is a rectangle such that the ratio of area of the semicircle to the area of the rectangle is 2 pi by 3. Find the length of the line segment TQ. We have been given a semicircle with radius of 4 units and there is a rectangle OSRU in such a way that OS is the radius and SR we don't know. But we know that the ratio of area of the semicircle to the area of rectangle is 2 pi by 3. Given to us that the radius is 4. So OP, OS, OT, OQ, all of them are equals to 4 units. So we can just go ahead and write that. Then what will be OR? OR will be the diagonal of the rectangle. If we are able to calculate SR, then we can easily calculate OR also. What we need to calculate finally is TQ. So to calculate TQ, first we'll try to find out what are the dimensions of the rectangle. We know one is 4 units. What is SR we want to find out. For that we will write down area of semicircle minus area of rectangle divided by area of rectangle equals to 2 pi by 3. Area of semicircle is pi r square by 2 and area of rectangle is length into breadth. So pi into 4 square by 2 into 4 into SR equals to 2 pi by 3. Simplifying that, we get SR equals to 3. Once we understand SR equals to 3, immediately we know that OU is also equals to 3 because OSRU is a rectangle. OU is 3 and OQ is 4. Obviously we know that UQ is equals to 1. UQ is equals to 1. That we will use it afterwards. Now to move forward to find out the length of TQ, the first thing and most important thing is drop a perpendicular from T onto OQ. If we are able to do that, then we can see that there are two similar triangles here, OTX and ORU. And for ORU triangle, we know all the dimensions. We know OR is the diagonal of the rectangle. We know OU is 3 and we know RU equals to 4. That means easily we can calculate what is TX and what is OX. If we are able to know what is OX, then we can easily calculate what is XU. If we know XU, then we can calculate XQ. We know TX, we know XQ, we can calculate TQ because it's a hypotenuse of right angle triangle TXQ. That is our approach to solve this problem. So first let's write down the similar triangles. Since OTX is similar to ORU by AS similarity criteria, corresponding sides we can write down. OT by OR equals to TX by RU equals to OX by OU. OR is diagonal of the rectangle, that is 5. So OT 4 divided by OR is 5 equals to TX we don't know, but RU is 4 units equals to OX we don't know, but OU is 3 units because SR is 3, OU is also 3. Now once we know that OU equals to 3, we can calculate what is TX and what is OX from here. Since they are similar triangles and corresponding sides are in same ratio or proportional, TX will be 16 by 5 and OX equals to 12 by 5. If OX equals to 12 by 5, then we can calculate XU. XU is OU minus OX, which is 3 minus 12 by 5, which is equals to 3 by 5. If I know that XU is 3 by 5, what I need is XQ. So I can add UQ, which is 1 unit. So I can write down XQ equals to XU plus UQ. that is 3 by 5 plus 1, 8 by 5. Now we have all the sides of the right triangle ready to calculate the hypotenuse. We have tx 16 by 5 and we have xq 8 by 5. We have to just calculate the hypotenuse tq now. So applying Pythagoras theorem, we have tq equals to square root of 16 by 5 whole square plus 8 by 5 whole square. So on simplifying, we'll have 256 divided by 25 plus 64 by 25 under root. Simplify that, we will have square root of 320 divided by 25. Square root of 25 is 5. Root 320 can be written as 8 into root 5. So length of TQ is 8 by 5 multiplied with root 5, which is option A. So that's one interesting example I have seen, and I just thought I'll share that with you. Please do let me know your feedback. Thanks for your time and support. Bye for now.